All right. So this is just the first part, the front page of the Unit 6 quiz. This is just a mini quiz because it's just one page, two problems. First, we're going to read the problem. We're just going to ask ourselves, what is this problem about? A biologist is studying the population of turtles. At the beginning of the study, there were 12,500 turtles. It is noticed that the number of turtles is always a quarter of the previous year. Complete the table to find the number of turtles for each of the following U's. Use the table to write the function. So I'm looking at this and I'm going a quarter of the previous years. I could express this in a couple different ways. I could say this is 25% of the previous year. I could multiply the previous year by a quarter, but this is telling me that there's a multiplier, right? The same kind of meaning as if we said double or triple or 4 times or half as much. Those are all multipliers or factors. So this is telling me that the common factor is 1/4. If you don't like fractions and you want to use decimals, we can read 1 divided by 4 is 0.25, which, while not something we're going to use in this, you might notice that that's 25%. That's what it means. So what's 25% of this? Well, times. So that means the first one, right, is just this one. The second one is going to be 3,125. So we got that by saying this is 12,500 times 0.25. Now the third year, well, it's the third row, the second year, year 2 is going to be 0.25 times that. So it's going to be what we got when we took this, multiplied it by 0.25, and then multiplied it by 0.25 again. 781.25. Now our input here, this is years, and our output is turtles. You can't have 0.25 of a turtle. So we could say 781 and say that we're going to round it. But we're going to be using the factors that give us the precise answer of this model. Oh, I got an extra 0 on the previous one, didn't I? So the point is, even though there aren't actually 0.25 models, if we just use this number, we're going to start to get a little bit off because we've rounded a value and then we're calculating based on that. If we do it this way, if we say, okay, this is going to be 25% of 25% of 25% of 12,500. This would be 195. Again, 0.31, maybe we don't write 0.31. That's not as big of a deal as can we calculate it accurately going forward. So that's why each time we want to say, look, I'm multiplying by 0.25 another time. So in exponent form, this is 48.8. So if I were to round this, then I'd really want to make this 49. So we want to make sure that if we're rounding properly. In exponent form, this is, we can see this is 12,500 times 0.25, 1, 2, 3, 4, 4 of them. So to the 4th, to the 3rd, to the 2nd, and the pattern continues. So this is to the 1st because we only multiply it 1 time. We multiply it 0 times. Right? We're not multiplying it by 0.25, so we're saying there are 0 common factors applied here. So in 6 years, we're going to have 12,500 times 0.25 to the 6th. We could get that a couple ways. We could say, well, this is going to be 12, and this is going to be 3. Or we could say, we could multiply it all the way down by 0.25, or we could just type this in, equals 12,500 times 0.25, exponent button, to the 6th. 3. This is rounded from 3.05. So you can see our function is whenever we have the number of years, what we do first is we take 12,500 and then we multiply it by 0.25 a certain number of times. And that number of times is exactly the same as the number of years. So we multiplied it once for 1 year, twice for 2 years, 3 times for 3 years. So it's whatever x is, that's what our exponent's going to be. Okay, number 2. You tell a number of friends about an interesting video you saw online. Each of those friends tells the same number of friends about it. This pattern continues, and there are no repeats in the people told. In other words, it's not like your friend told, John told Amy, and then Amy told John, and then John told Amy. It doesn't go back and forth. It's saying each time there's another round, it's entirely new people. So we're continuing to increase the number of people who have heard about and watched this video. So what we do is we pick it up in the 4th round, and we say there are 256 people. So I'm going to say this is round 4, and there are 256. And round 5, there are 1,024. Now, the other thing that this tells us is that it forms a geometric sequence. So that's telling me that there must be a common factor. So this is the rounds. This is the watched by. This is how many people watched it. So we're told it's a geometric sequence. In other words, that there's some multiplier here. So I'm trying to figure out what is the number that multiplies to get us from 256 to 1024, because if I know that multiple, that factor, it's going to tell me how to go down and up the table. So 256 times what is 1024? 256 times what common factor is 1024? So take 1024, divide it by 256, that gives us 4. Our common factor is 4. So this is the result of 256 times 4. So that means the 6th round is going to be 256 times 4 times 4 again. Right? We're going to take 1024 and multiply it by 4. And then multiply it by 4 again. So this is 256 times 4 to the 3rd power. 256 times 4 to the 2nd. 256 times 4 to the 1st. Whoops, times 4 to the 1st. 256 times 4 to the 3210. So that means this must be 256 times 4 to the -1. And this must be 256 times 4 to the -2. And this must be 256 times 4 to the -3. Now, the astute ones among you who are really thinking about what's happening here, you'd say, well, if I go times 4 times 4 times 4, that must mean that I go divided by, divided by, divided by. And indeed, that's what these things mean. To the -1 means instead of multiplying by 4 once, it means dividing by 4 once. This means dividing by 4 twice. This means dividing by 4 a third times. But our exponents are a way of symbolizing that in a shorthand way, and I can actually calculate that using my exponent button, and I'll show you in a little bit. For now, though, we want to write a function. So our function is 256, that's what I do, and then it's times 4, and then how many times do I multiply it by 4? Well, for round 7, I multiplied it 3 times, so that's a third exponent. For round 6, I multiplied it twice. For round 5, I multiplied it once. So this is my x value. I'm saying x is going to be the round. So round 5 means x equals 5. When x equaled 5, my exponent was 1. When x equaled 6, my exponent was 2. When x equals 7, my exponent is 3. So it looks like anytime I have an x here, it looks like my exponent is 4 less. So 4 less than x, we write that x minus 4. Now there are lots of different ways we could model this. We could say, I'm just going to call this round 0 and renumber it. And that would be fine. The key is, does your table, the way you're labeling your inputs and outputs, does it match your function? That's what I'm going to be checking. And then can you apply that? So if we say how many people watched it in the first round, well, since I labeled this way, where I said the 4th round means x equals 4, I'm just going to say when x equals 1, what's f of 1? Well, that's 256 times 4 to the 1 minus 4, or 256 times 4 to the negative third. 4 to the negative third equals 4. You can see if you do it the other way, 256 divided by 4 is 64. Divided by 4 is 16. Divided by 4 would be 4. So it works either working backwards, divide, 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 or by using the function. All right, so that's all we got for our quiz for tomorrow, Friday. The back is going to be something we're going to quiz on in just a couple days, because I want to give us just a little more practice on that with homework and classwork. So good luck, and we'll see you in class taking the quiz.